So here we go. Multiplying polynomials. I can distribute and use a box to multiply. That's what we're doing today. Two things. We're going to distribute. Now, when do we use the distributive property? When we have one term or one monomial times a polynomial, then we use the distributive property. Okay? And if we have two binomials, then that's when we would want to use a box. Okay, but real quick. I need just some paper. I have like a little piece of paper somewhere. Yeah. Nope. Here we go. All right, real quick though, before we do this, if I have something like 4x times x, what does that equal if I use exponents? 4x squared, right?
Yes.
So if I have like 4x squared times x to the third power. So if I did like, remember what squared means, or to the third power? That means how many times we're multiplying the base by itself. So this would be like 4 times x, and then this one would be x times x times x. Well, how many powers of x is that?
5.
It's 5. So it'd be 4x to the 5th power. So what do we just learn that we do with exponents? You just add them. When we multiply, we just add exponents. But they have to be the same base, right? If I had 4x squared y squared, I can't do that. I don't add those exponents because these are different. Okay? All right, so if I got something like this, right, and I'm going to distribute, because I have one monomial, this is one term, times each of these two terms. When I draw an arrow like that, that means I'm multiplying. Okay? So I can multiply this term by this term, and then there's a little 1 on that exponent, right? And then for this y, there's also a little 1 there. That's just understood. So when I multiply 4 by 3, what do we get? 12. So I get 12 there. And then I have x squared times another x. Well, we just remembered that we add those exponents, right? So it'll be x to the power of 3. And then I just have y. There's no other y to multiply for that one. So 4x squared y times 3x makes 12x cubed y. Okay, now I'm going to take that term times the second term in my binomial. Okay, so think of there's a 1 in front of that y. There's a 1 on the exponent of that y. So that'll just be plus 4x to the power of 2, and y to the power of what? 2. 2 because this has a y and that has a y. Okay? So real quick, if I made another one up, like 3ab squared times 2a plus 3b. Just real quick, if I made up another one and I'm going to distribute, remember, this is all one term. This is a monomial. So 3 times 2 is 6. A times a is a to the power of 2. And this term has a b squared. There's no other b squared, but I just keep it. And then 3ab squared times this. 3 times 3 is 9. There's no a to multiply with this. B squared times another b makes b to the 3rd. Okay? Now, you add and subtract with like terms. But when you multiply, you make new terms. So they don't have to be like, because you're making new ones. Okay? Okay, let's try this one. Let's try example 2. So I have negative 2x times everything in this polynomial, trinomial really, right? So we're going to take negative 2x times 1. Well, not just negative 2x. How about negative 2x times 3x? Well, negative 2 times 3 is 6, right? And then I have x times x. That makes a new term, right? It makes x to the power of 2. And then, lastly, I have negative 2x times negative x squared. Well, negative times negative is positive 2x to the power of 3. Okay? Wouldn't the 6 be negative? Oh, yeah. No, you're right. It would be. Does this, of course, I'm not using an erasable one, am I? No, yeah, this 6 is negative because it's negative 2 times negative 3. You're right. Well, good thing is I'm not done with this one because since this is only in one kind of variable, I can put this in standard form, right? Like when you put these on your Amplify assignments, it'll only accept it in standard form, which means the highest degree term has to come first. So I'm going to put this with 2x to the third power first, and then go in descending order. So then minus 6x squared, and then minus 2x. It'll be a minus 2x because it's negative, because negative 2x times 1. Okay? Okay, so we can do this kind of like hopping over in distribution when we have a monomial, one term times a polynomial. But if we have a binomial times a binomial, we have actually we have two special methods for that. One that you really know is the box method, and the other one is called FOIL, and it's basically a boxless box. It's the box without the box, if that makes sense. Okay, you all know these. You all know box, right? So you're gonna multiply this with a box. So we draw a box, window pane, right? Okay, one of your factors goes on the top. It doesn't matter how you arrange it, but I'm going to put this up here. So just so one term gets, a piece of the box, and then on the other side we go down here, minus 4. Okay? All right. And now what we do is we multiply on the sides to fill in the box. So x times x makes x squared. Okay. X times 3 fills this box. So x times 3 is 3x. And down here, negative 4 times x makes negative 4x. And then in the bottom right corner is just our two constants. So negative 4 times 3, bless you, is negative 12. Okay, now I color-coded these for a reason, because now that you fill in the box, your answer is the polynomial that you get when you string all these terms together. However, these are in red. Why are these both in red, do you think? You can actually add them together. Yeah, because they are like terms. Okay? So when I put those together, my answer is x squared, negative 4x and 3x. When you combine negative 4 and 3 together, you get minus x and then minus 12. Do you have a pass, sir? No? Okay. Okay, so this would be our final answer. Okay, this is the final answer. That is a quadratic trinomial. That's what we get when we add it all together. Okay? Now, drawing the box is great, and you can draw a box every single time if you want to. Okay? But there is something else that you learn. You should have learned it in Algebra 1, but maybe you didn't. It's called FOIL. FOIL, the words in FOIL stand for this. First, outside, inside, last. First, outside, inside, last. Okay, so what that means is that just tells you what terms to multiply. So F for first means the two first terms. Okay, so if I were to translate that into the box, that's this box right here. O, outside, means the two terms on the outer edges of the expression. So that would be those two. So in this case, it's the x times -4. So that's this box right here. I for inside terms. So that would be the two terms right on the inside. Okay. And then L for last terms. That would be the two terms on the end. So that would be the 3 and the -4. Okay. And then the ones that we can typically combine are typically going to be the O and the I. Those are typically going to be combined into one. Okay? So you're going to notice on the notes, like I've got the box drawn for you, but if we can move away and do FOIL, that's great too. All right? Because if you go on past this class, all right, if Algebra 2 is not the end for you, then drawing a box is going to be kind of annoying because this will be one small step in a much bigger problem. Okay? All right, let's try another one. Okay? I'll go ahead and draw a box for this one too. So, we're multiplying two binomials. So let's put 3x minus 4, I'll put that on the top, and 5x minus 2 on the side. Okay? So we'll multiply these. 3x times 5x is, whoops, wait, what color was I using? I want to be the same. Blue, okay. 15x squared. Okay. And then, so that's like the F in FOIL, right? I'll try to do it at the same time. That was the F in FOIL. Okay. Now I want to do the O in FOIL, the 2 on the outside, so I'm going to do this -2 times 3x. What's -2 times 3x? -6x. And then I'm going to come up here to the I in FOIL, which are the two inner terms. In this case, it would be -4 and 5x. That'd be -20x, right? And then L, our last terms, -4 times -2, that's a +8. Okay. Now my answer is the polynomial that I make of everything in here, okay? So I'm going to drop the color at this point. But 15x squared, these are like terms, right? We can actually add those together. So -20 and -6 makes -26x. If you don't know that, in the calculator you would type, are we okay? Oh, you good? Okay. We would type -20 plus -6 is -26 and plus 8. And this would be our answer. Okay? Pretty good? Okay, the last two, these are just special cases, all right? So let's see what happens when we have these special cases. So if I'm going to do x plus 9 times x plus 9, the F in FOIL, this first terms, actually let me write this down, x plus 9, x minus 9. Okay, so this is x squared. And then O in FOIL, the outer terms, x times -9 is -9x. The I in FOIL is the inside terms, so x times +9 is +9x. And our last terms negative 9 times positive 9. That's negative 81. Okay. So in this case, what do we notice that happens here? What's so special about this? When I go to write my answer, I start with x squared, and then what do I put? There's no x term, because these cancel out. They become a zero pair, right? So there is no x term. I mean, I could do this. I could put plus 0x minus 81, but I don't need to do that. This is just my answer, x squared minus 81. So O and I cancel out. Okay? So that's just kind of a little special case there. All right, and then last one. People do this one wrong all the time. All the time. Don't be like people and mess this up, okay? You cannot. If I see this, x plus 2 squared, I cannot distribute the squared. That's not a thing. That doesn't work, okay? What this is actually saying, x plus 2 times itself. That's what squared means, right? So it's not saying distribute the squared. It means x plus 2 times x plus 2. So you can set up your box like that. X plus 2, x plus 2. You can't distribute a squared. I have a Mean Girls meme somewhere in my room about that. Oh, it's on my cabinet at the bottom. You can't do that. All right, now let's fill out the box. X times x, x squared. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. Okay, these are my like terms. Combine those together. So my final answer is x squared plus, those added together make positive 4, so plus 4x, and then plus 4. Okay? Okay. Now, the box is great. You like it. It's your comfort zone. Great. If you want to take it a bit further, if you're like, I know that I'm going on past Algebra 2, teach me more, okay? If you notice these patterns, you can multiply these special case ones, like number 5 and number 6, very, very quickly, okay? So the pattern, if I have something like example 6, I have a sum squared. Just follows this pattern. First term squared plus 2 times the product. Why 2 times? Because there will be double of these, right? And then plus b squared. So if I want to do x plus 4 squared, and I want to use the pattern, no box, no work, I just want to use it, I'm going to follow this method right here. The first term would be, anyone know? The first term squared. So that would be x squared plus 2 times the product of these terms. So the product of x and 4 is 4x. But I would have 2 of those, right? So it would be plus how many x? 8x. Plus the last term squared, 16. And there's a very similar pattern if it's a different squared. The only difference is that that second sign. So this one would be x squared again, but it'll be minus 6x, because it'll be the product of these times 2, so 6x, and then plus 9. Okay? And then the last special pattern is if I have the same binomial that I'm multiplying, but one sign is a plus and one sign is a minus, like example 5. The trick there is that there is no middle term. It's just a squared minus b squared. Like this one ended up being x squared minus 9 squared. So this one would just be x squared minus what? 25. Okay? So for things like this, if you notice if this pattern worked for you, awesome. If not, and we're drawing boxes, totally fine too. Okay? All right, let me stop this.